This is a topic a lot of students find difficult, and I can see some places where you're going to lose marks just for layout, just for the way you've written it, even if all the answers are correct. So one of the things that students find difficult is how many numbers there are. So I want to track what you've done with each of the numbers mentioned in the question. In the past, customers certain library had the number of times spent is mean of 32 and standard deviation. So this is the historic data. And where do they actually say we think it's a normal distribution? They don't. So we're going to assume, okay, interesting. I'm not sure I like that very much, that they tell us the mean. And I guess if they tell us the mean and the standard deviation, and we know time is a continuous variable, but there are other distributions that could, anyway, that doesn't matter. Let's assume it's a normal distribution. So I am going to do the thing that I mentioned previously, and I will mention many times, and I have to mention to all students. It's going to help if we write down what x actually is. Now I know you did do that, sort of. You wrote that the mean is that and the standard deviation is 8.2, but you didn't actually say that we were using a normal distribution. It's going to matter later. Well, it's not going to matter. It's going to contribute later to problems if you don't get into the habit of always writing down what the distribution actually is in statistics. Okay, so there's the historic data there. Then they say we've got 5%, and also in these questions, right, they can give this information in all sorts of orders. Sometimes they say the first thing they tell you is the significance level, and then they tell you the sample size, and then they tell you this, and then the mean, and then maybe they don't even tell you the standard deviation until right at the end, or they, instead of telling you the standard deviation for the population, they tell you standard deviation for the sample, which you can use as the standard deviation for the population. But you know, it's really confusing. All these numbers, you have to get them in the right places. So we've got the historic data, and the whole point of this hypothesis test is to challenge the mean. It's not challenging the standard deviation, we're challenging the mean, the 32.5, which is what you've got here as your H0, but you're going to lose a mark because, for two reasons. You would lose the mark anyway because you said H0 equals 32.5. H0 doesn't equal anything. H0 isn't a number. H0 is a statement made by a person, and H0 is the historic person, and H1 is the new person who's claiming that historic person's wrong. So H0 colon is the statement that the mean of the population is 32.5. H1 colon H1 is the statement that the mean of the population is not 32.5. So this person H1, they're not saying, it's not, people don't spend half an hour in there, they spend way more than half an hour. And they're not saying people don't spend half an hour in there, they pop in and out, they're gone in 10 minutes. They're not saying either of those. They're just saying, I don't think you're right about this whole 32.5, I think you're wrong. So let's look at the question and see where we can find that. Yeah, has changed. So the person is saying, what is the, I believe, this is what H1 is saying, the person H1. They are saying that the mean of the population, as in X, as in the time spent by an individual in the library, the mean is not 32.5. Now what that means is that when we get down to the very bottom and we're looking at whether or not the result is significant, we're not going to use 5%, we're going to use 2.5%, and that's the only time it's going to make any difference at all, is right at the end, because the person has not nailed themselves down to the left or to the right, they've just gone, it's just that you're wrong. So we split that significance in half, in this case into 2.5 each end, which you've got here. The other reason that you're going to lose a mark is that you haven't said what mu is, and this is an OCR thing. AQA and Edexcel don't take a mark off for this, but in OCR, which is what we're now doing, you have to say what mu is. So mu is the mean time spent, I'll pause it. is the mean time spent by a customer it's the mean of all the customers. No, so it's not a customer, it's the mean of the population. It's the mean time spent by customers in the library in minutes. The mean of the whole population of times that people spend in the library. So even though you know exactly what you're doing, we have already dropped at least 1 mark, if not 2, because didn't write this, didn't put them in, and didn't write that. Okay, next we get our sample. 50 is the sample size. Then we get the result of those 50. This is the mean of the sample. I didn't ask the whole population. I didn't watch the library for the whole rest of my life and everybody else's lives forever and do all of the whole population of everybody using the library ever. I just took 50 people and found the mean of the sample. The sample is size 50. Okay. Now we need to find out whether or not this 34.4 is significant or not. 34.4 is higher than what I was expecting. I was expecting the mean of the sample to be 32.5, or at least H0 was expecting that. H0, historic person, is expecting the mean of the sample to come out to be 32.5. This axis is the mean of a sample of size 100. It isn't, here's the important bit, it is not X. That thing that I was expecting to be 32.5, that I'm now saying, oh, I didn't get 32.5, I got 34.4, that's quite big. That thing I just found is the mean of a sample of size 100. It is not X, it is X bar. X bar is the sample, X is the whole population, X bar is the average of a sample of size 50, not 100, that was another question I was doing, of size 50. So you can't go in your calculator, you're trying to find this area, and we're going to compare that with 2.5 and see if it's small enough. If it's really, really small, smaller than 2.5, we'll reject H0. If it's not, if it's still quite big, if it's near, you know, anything bigger than 2.5% basically, we're just not going to reject H0. So that's what we want to find. We have to use the calculator to find this when we go to the Sorry, that was my granddaughter. So where did I get to? X bar. Yes, so what we need to put into the calculator is X bar, and I know that that's what you were doing here. You didn't say it, but you know that the thing we need to put into the calculator is the distribution of X bar, not the distribution of X. So the mean of X bar is the same as the mean of X, but the standard deviation of X bar is different. Now what you should have here is you've written the standard deviation there, and when we write the distribution, what goes on the right hand side is the variance. I know that's a bit annoying, but this should be the variance, not the standard deviation, although I know it is the standard deviation that you put in the calculator. So what it should actually be is X bar is distributed normally 32.5 comma 8.2 squared over 50. So you divide the old variance, the population variance, by the sample size to get the variance of X bar, and X bar is the mean of a sample of size 50. It's very, very confusing to fully understand it, but it's not confusing to do because it's the same every time, same steps every time. Okay, so that's what we're going to put in the calculator, this standard deviation and this mean. Why are you doing the lower is naught and the upper is 30? That's just going to give you a half. Now this, I claim, is because of not drawing little pictures of the normal distribution, which is what we talked about in this question, drawing pictures of the normal distribution, and also in this question, drawing pictures of the normal distribution. And maybe this is the point that we've reached where it's going to start to cause a problem. So what you've actually done here is you've said, if I've got a distribution with this standard deviation and this mean, what is the area from, oh hang on, it makes no sense, from 0 to 32.5. Maybe I'm not sure what you're trying to do. Are you trying to find this area? Because that will be a half. Because 32 point, yeah. Oh wait, no, it's no, look what you've got here. You're saying that the mean is now 34.5, not 32. You're saying that you've got a distribution with a mean of 34.5. We haven't got that at all. We've got the distribution of x bar, which has a mean of 32.5, which is what H0 is claiming, and then we've got a result from our sample of size 50, which is 34.4, and what we need to find is this area here. I'm going to get rid of this because this is not relevant at all. This is what we need. That area. That area is the probability that x bar is bigger than 34.5. That's what we need to find. And then, which you seem to have done here, we are going to compare that area, this area, we're going to compare it to 2.5, and if it comes out bigger than 2.5, then there is insufficient evidence to suggest that the mean time has changed. Yes, almost perfect. The only thing I would say is try to make your conclusion a 3-part conclusion. So part 1 is whether or not your probability is big enough or small enough. Then part 2 is whether or not you're going to reject H0. Do not reject H0. And then part 3 is the words. And when you do the words, we need to use as much of the question words as possible. So you've got insufficient evidence to suggest that. Now, what did the question say? The mean time spent by customers in the library has changed. Now, you've said the mean time in the library has changed. That's honestly more than most students would do. So it's way more likely you're going to get this mark than most students. Most students say there is insufficient evidence to suggest that the mean time has changed. Didn't say customers, didn't say library. Not going to get the mark. You said mean time, but you missed out. If you look at the question, it says the mean time spent by customers in the library. And you've just shortened it to in the library. So there is a possibility that you would lose a mark here. Mean time spent by customers. Just copy every word of the claim in the question to be sure that you're going to get that extra mark. So a lot of these marks will have gone. Some of them because of the way that you were writing things and not writing things. And I would claim all of them are for that because of writing things. Honestly, that's what I would claim. That if you'd drawn this picture, you would know that you didn't need to put the mean as 34.4. I'm, to be honest, not entirely sure what you put in. Upper is 32. See, what you seem to be doing here is well, that's not a very nice distribution, is it? But anyway, you seem to be doing a distribution with a mean of 34.5, and then you're finding the area from 0 to 32.5. Why? That's what seems to be happening. So we have some work to do on hypothesis test, but it's the same work that every other student has to do. This is so standard for this to be the first one I've seen for it to look like this. I would be surprised if it didn't. Honestly, I really would. This is what a student's hypothesis test looks like when they know exactly everything about the hypothesis test, but they've never actually done one on paper and handed it in and had it marked carefully. So you're totally normal. Don't worry. We'll fix it very, very quickly. Not a problem. It's really good. What you've done is really good. We just need to tighten it up.